notes. Going over the homework. Alright. A lot of people do. Let me ask you. How many hours are you at school? How many hours are you at school? 8 what? I see people just guessing units or leaving units off. How fast should you drive on 1277? No, I said how fast should you? 55. But I see people put 55 hours. No, the road right there. This is 147. But my point is, look at the units. It should be in miles per hour, not hours. So your speed is going to be some measure of distance over time. How many meters per second you're traveling at, how many feet per second, how many feet per minute, or how many miles per hour. Which brings me to another point. M is for meters. MI is for miles. MIN is for minutes. I've seen someone put miles per minute as M divided by M. That doesn't tell you anything. That's wrong. That's meters per meter. Another thing is some people would put like kilometers per second as KPS. That means nothing. If you want kilometers, it's km per second. The only exception to this is for miles per hour can be written as mph. That is the only time you will write a P to represent the slash. America is very weird when it comes to units. We still use miles. Everywhere else uses meters. Another thing. A, lowercase a, is for acceleration. Capital A is for amps. Like how many amps of current are running through the wall. Or how many amps does your car battery produce. So lowercase for acceleration, capital A for capitalization. For amps. Another thing is D versus lowercase d versus capital D. This is for distance. This is for density. If you see me lowercase something, if you see me capitalize something, copy what I do. There's a reason. So, let me give an example of what I'll do. Another thing that I've seen people do is I'll see people just taking numbers and giving them to variables. One problem that I'll probably assign for homework is something like this. You are traveling in a Dodge 1500 with red number 5 stripes. You pass a sign that says 55 miles per hour. The truck is 0.5 meters off the ground. The truck has 4 tires. The owner of the truck has $22 in his wallet. He travels 5 miles, passing a 6 o'clock diner with a sign saying 85 degrees Fahrenheit in front. He does this in 0.1 hours. What is his speed or velocity? So, there's a lot of numbers in this problem. You have to actually read the problem and see what it's saying. Almost all of these numbers are unimportant. What you're trying to find out velocity or speed, so speed is equal to distance over time. So you need to ask yourself, what distance did he travel? He travels 5 miles. And how long did it take him to travel 5 miles? He does this in 0.1 hours. So your distance is 5 miles over a time of 0.1 hours. That gives him a speed of 50 miles per hour, which is the same thing as 50 miles per hour. Box your answer. You can't just be picking out random numbers and assigning them to random variables. You have to actually read the problem and ask yourself what the variables are. So we're trying to find speed. Speed is distance over time, so what distance did he travel? You might have looked and saw 55 miles an hour. That's a speed. But that's just the speed written on a sign. That's not the speed he's traveling at. So initial velocity is how fast you are moving at the start. What's the difference between velocity and speed? No, they're not constant. I don't know what gave you all that idea. Speed is distance over time. Speed with a direction. So it's how fast you're moving at the start in a certain direction. I usually leave off the direction, and I treat velocity the same as speed. But velocity has a direction. We usually indicate it by positive or negative. Positive means moving forward. Negative means moving backwards. Compared to the start, we usually let the starting number be positive. Again, you're going to have to read the problem to understand what the initial velocity is. You can't just look for numbers and just write the first number you see. Is everyone done with the top part? Not yet? Oh yeah. So a car at rest this statement is at the beginning and it's telling you what the car is doing at the beginning. You should infer from this that the initial speed is 0. It could either be 0 meters per second or 0 miles per hour, whatever the problem's units are. Is everyone done with this paper? So, final velocity. Final velocity is how fast you're moving at the end. Note that this is not going to be the last number in the problem statement. Again, you have to read. So I could do like this. A car will eventually reach a speed of 55 miles per hour after starting at 10 miles per hour. So, reading the problem, a car will eventually reach. This will be your final. After starting at, because you started, this will be your initial. Another example is a car comes to a stop. So if you're coming to a stop, that refers to your final. Unless you begin stopping. Unless this is the first thing you do, this is going to be your final. So acceleration is how much the speed changes by. So for example, a car gains 5 miles per hour every second. This is how much your speed is changing by. It is changing by 5 miles per hour every second. So your acceleration would be 5 miles per hour every second. Another example is suppose I said A equals 10 meters per second squared. This second squared can be broken out like this. 10 meters per second every second. I can expand one of these seconds out. So what this is saying is you are gaining 10 meters per second every second. Or another way of wording it is every second, you gain 10 meters per second. So VF minus VI, this is your change in velocity. Is change in velocity. It's how much your speed has increased, or will have what? No, this is not star tested. How much your speed has increased since the start. So if you wanted to solve for final, your final would be equal to your initial plus your change. So your final speed is whatever you started with plus your change in velocity. So another thing that I've seen is people using the triangle incorrectly. So when you set up your triangle, the triangle never changes. If I were solving for VF minus VI, circle what you start with and write it down, VF minus VI, and then what's rest is going to be your equation. So A times T. So if you instead were solving for T, copy your triangle down and circle T. What is left is the rest of the equation. So it's this over that. So you're solving for T. So what you're left with is this over that. So it should follow. So let's do an example. You increase your speed from 5 meters per second to 10 meters per second and was accelerating at 2.5 meters per second squared. How much? Oh, by the way, this is for people at home. The code word of the day is apple. Code word of the day is apple. If you're not a remote learner, you don't need to pay attention to that. So check to see if they're watching the video. How much time did you spend accelerating? So we're dealing with acceleration. We're dealing with acceleration. So let's start by figuring out what equation we're going to have. So so we're solving for A. A is VF minus VI divided by T. So this is our equation. We need a VF, a VI, and a T. So what is our initial velocity? Well, that would be what would go at the start. We begin at this number. So we're going from 5 meters per second. And then we go to 10 meters per second. So that's what we end up at. How's our speed changing? Well, that's our acceleration. And my bad. I made a mistake. It's okay. Yes, be quick. It's supposed to be like this. We're solving for time. Our acceleration is 2.5 meters per second squared. We're solving for time. Since we're solving for time, we know our answer is going to be in either seconds, minutes, our hours, our years, months, days, weeks. We know what unit to use based on our acceleration. Our acceleration is meters per second squared. That means 2.5 meters per second every second. So our units are going to be in seconds. So plug this in. Note, VF is 10. VI is 5. And our acceleration was 2.5 meters per second squared. I've seen a lot of people get to this point. They did everything correctly. And then they get some random number. Make sure you're putting in the calculator correctly. You should be putting parentheses around this and plugging it in. Or you can do it in your, you can look and do the numerator first. 10 minus 5 is 5. Divided by 2.5. Well, that is 2. Or we know our units are seconds. So we put 2 seconds. Alright, one last example. Huh? No, that was for chemistry. No. Oh, yes. Like, homework, yes. So, you are traveling. Oh, that reminds me. What was my cheating policy? And what else? So if you let someone copy First of all, no, not that homework. How many of y'all realized y'all had different numbers? Y'all all had different homework. Dylan, how did someone end up with your numbers? Luckily, they only copied one page. I'll let it slide. This is your only warning. So you are traveling at 100 miles per hour. What? So as long as they, no and yes. Yeah. So here's the deal. If you are discussing together and you're like, what is my initial? It's this. What is my final? It's this. Here's the thing. What's wrong? So what would be your initial? Our initial is 20. Let me see. You wrote a 20 down. I'll write a 20 down. That's cheating. You can sit here and discuss it. Yes. Copying down is the number one thing. Because I've seen people. Oh, did y'all hear the story 2 years ago? Yeah. I got homework written in French. The entire class decided to write in French, and there's only one French girl in the class. Yeah. So I'm grading. I'm like, that's misspelled. It's exerts. No. It's the French word for exerts. It's almost pronounced like exerts. I'm probably misspelling it. I don't know French. I'm like, exercise. They misspelled that. I'm like, no, that's not right. I'm like, because French is pronounced very, very weirdly. And then they used, instead of columns, they don't use the word column in French. It's something else. But I noticed everyone's copying in French. I gave everyone a 0 in that class. You got a 0 too. No. Yes. Yes, extremely blonde. Another thing is this. So I saw some people do this. So there's a brand name. I'll just flip it over. So another example is someone put equals 50 divided by 20. And they accidentally marked right here. And then they did equals 30. So the person, and again, this is wrong, but I saw someone wrote 150. They then went down a line and did 20 like that, copying it. And then very carefully under the 2, they put equals, and then outside, there was there was a huge space. Like they're literally copying and pasting every mistake, every line. I had one person write right here, and then over here, and then they write a word 150, and someone would copy that exact same thing. I am extremely good at identifying if someone, when writing, is actually thinking about it and coming up. I'm I'm very good at catching mistakes. So I taught forensic science, and we analyzed handwriting in that class. Like whether or not it goes downstroke, spacing. It's very easy to tell if someone was looking at something and copying it down or figuring it out because you don't naturally do that. Mm-mm. I'm very similar. Usually, it depends on whether or not I care enough to give everyone zeros or try proving it. Alright, this is the last problem, and then we're done for the day. You are traveling. Wait until I finish this. Okay. You are traveling at 100 miles per hour and hit the brakes. You begin slowing down at negative 10 miles per hour per second. What is your final velocity after 7 seconds? So we're trying to solve for final velocity. We're slowing down. Slowing down is acceleration. So our acceleration will be negative 10 miles per hour per second. You are traveling at 100 miles an hour, so that's your initial thing. We're given 7 seconds. And we're looking for final. So we don't have a triangle for final directly, but we can find out how our speed has changed. So let's solve for change in velocity. So our change is equal to acceleration times time. So that would be equal to negative 10 times 7. So we got a change in speed of negative 70. This means we lost 70 miles per hour. So you slowed down by 70 miles per hour. And it's asking for final speed. Final speed is going to be your initial plus whatever you changed by. So you started at 100 miles per hour, and you changed that by negative 70 miles per hour. You lost 70 miles per hour. And your final speed would be 30 miles per hour. Another thing that I suggest is after you get an answer, you go back and think about it. So if you start at 100 miles an hour and you're losing 10 miles an hour every second for 7 seconds, you would expect your speed to be 30 miles an hour. I've seen answers like this: 7,000 miles per hour. Does that make sense? If you're going 100 miles an hour and you hit the brakes, how could your speed be 7,000 miles an hour? Another thing I've seen is this. Someone put 41 divided by 55 equals 1.3. They put it in the calculator wrong. You can look at this. This ratio is not 1.3. It's less than 1. So make sure you put it in the calculator correctly. So that's it for today.